You will be amazed about how fast this is going to take. Now, this method I'm about to show you also works if, let's say, this hole had a 30-degree chamfer and all you have is just the 2D geometry and you do not have surfaces, and all they give you on the print is just the major diameter of the countersink, and then they tell you to go 30 degrees down from there, then this is a good method. So let's go ahead and start and you can see what I'm talking about. First thing you need to go is NC 2-axis contour. We are going to double click the very top of the chamfer, so this line right here. We're going to hit done. I'm going to select my tool. It's going to be a 1/2 inch end mill, tool 2. So I just hit 2 tab, 2 tab, 2. We're going to go 7500, feeding 120, plunge rate of 120, and we're going to call this the 1/2 inch finisher. Hit OK. Alright, not too complicated. Go to taper angle and type 45 degrees. Now, if you do not have this option and it's darked out or grayed out, rather, then you might not have the license to do so. Some require, I believe it's a 2-axis advanced license, will allow you to have this. But if you, again, most of you probably will have this taper angle. So all you need to do is go to your Z depth and know what size chamfer it is. I'm just going to guess for now. We'll say 50 thou. And then this is important. You want to step over, because you're using a square end mill, about 2 thou. And we can look at the time on this after I get out of demo mode. I'll show you at the very end when I plug my key in. But for now, just plug in 50 thou, stepping over 2 thou at a time. And anytime I 3D, to make the post a lot shorter, so when you post it out it's not as many lines, I like to change a few things. The main thing being your curve tolerance. So I'll make that 2 thou. And this mainly applies if you're using 3-axis cut, but for now I like to make my curve tolerance a little higher. And I'll show you how to check if that even matters. I'll show you how to check to make sure it's shortening your program or not when we start posting. The lead in move, we do not need to really lead in. If you're plunging on aluminum, or even steel for that matter, at 2 thou, it's not going to hurt your end mill. I mean, if you take a brand new end mill and then look under a microscope after you do this, yeah, it might burn up the tips a little bit. But for a small chamfer stepping over 2 thou at a time, it will be perfectly fine. We're going to hit OK. And then we want to select on the outside and hit accept. So now I'm going to hit Control 2 and look at it in the front view. So as you can see, it's an exact 50 thou chamfer. Another way to check that is hit ZDE to analyze the distance from that line to that line. So yep, 50 thou. If you want to go a little bit beyond that, just to make sure that if your square end mill had a small radius on it, it would leave a weird step at the bottom. So let's go ahead and make it a little deeper. So we're going to say 60 thou. And again, whenever you're drill milling, a lot of people will put a 20 thou chamfer. In Surfcam it may look really big, or in your mind it may look really big, but a 40-50 thou chamfer usually looks pretty good. Like this chamfer right here looks really big in our viewport, but when it's on in reality, if you hold the part in your hand, it might be really small. So put a nice big chamfer on things, or radiuses, if you're making a part for yourself, a hammer or anything like that. It will always it will always look better than a sharp edge or a tiny little 2 thou chamfer going around. Other than that, that will conclude our programming. And again, I like to personally set up before I start programming. That way I know exactly what tools I have in my machine. And as I can see here, our finisher needs to be tool 4, so let's go ahead and change that. Anyway, so I like to generally set up before I program. That way I know exactly what tools I have, where my 0 is going to be, and then I jump into programming. And another reason I do that is because if I'm already set up and I have my rougher touched off and I get my roughing end mills already programmed, which this is in demo mode, it won't show it. But anyway, if I get my roughing program finished, I can go ahead and start running that roughing program while I'm programming everything else. So while it's pocketing out all of this material, which will take a minute, I can go ahead and start programming the finishing passes. A lot of people that I've trained get in the habit of sitting down, programming the entire part, and then they start machining. Well, that's a lot of time wasted whenever, if you do know what you're doing, you could be roughing all this out, and while it's running, you could be at the computer programming these finishing passes. Because once you get in the habit and you're really fast at programming, I can program the drill mill standing up. I don't have to sit down. I mean, you can, but I can program that in 1 to 2 minutes. And while it's doing its finishing passes, I could program this drill mill, and by the time the machine stops, I already have the post ready to go for the drill mill cycle. And these small time differences will be the difference between $2 an hour, whether you're an expert or an intermediate machinist. These small little things like running your program and programming your part at the same time that people will start to notice. And you will be very surprised. You might even inspire others to do the exact same thing because they realize how much time you're saving. And you might also think it's really stupid and you want to sit there and program the whole part. This is just my suggestion. You don't have to run the program and program at the same time. A lot of the times if you got one part, you might want to stand there and watch the tool run. But I've been running mills for 4 to 5 years now, and I'm confident with my toolpath to know while it's pocketing all this out that I can go in my programming room and be confident in the fact that my tool is not going to break or load up. Or now it can happen, the coolant can stop and then all of a sudden my tool load up, but I've blown up enough end mills to know that once it's gone it's not going to be cutting anymore, so I'm not really too worried about that. Anyway, we will conclude this video and move on to our last and final Surfcam video before we start running the part.